Welcome back, everybody. Let's talk storage, LAN, and WAN networking. The N in NAS is for notorious. So I just got nasty. I grabbed a random quotation here. 1984, the number of internet hosts has surpassed 1,000. Now we all have like that many VMs in our basements. So I wanted to just kick this off based on some recent conversations, frame it, and let her rip. I heard a comment that this is why I'm here. So we will dive right in. Number one, let's please stop making the same mistakes. We'll touch on a few of what those are. Number two, stop blaming your storage system for every network issue. And I've noticed that when you bring in a new open source based solution, people immediately blame it for everything. The coffee maker doesn't work, it must be the NAS. And from a recent conversation while setting all this up, do not build the highway for your 2 a.m. traffic pattern. Thank you very much. The telecom industry is famous for over-provisioning. We internet nerds with our open source OSs are trying to squeeze every possible oversubscribed dollar out of everything. So when you have that nifty gigabit service that showed up in your neighborhood, people start watching their favorite shows and you name it and talking to grandma in the old country, and suddenly your gigabit is about 300 megabit if you're lucky. So over the years, we've all bumped into jumbo frames and people thinking they are the panacea to all things networking. And I got some great feedback. Okay to read this, Rodney? Okay, so I'll read it back to our author. So, jumbo frames, they are meaningless on the LAN. Things were expensive back in the day when sending 1,500 byte packets was a challenge because CPU overhead would simply not keep up. But now we have offload engines. They get assembled up in a big old 64K byte packets. And you may still have issues when you go into, say, UDP traffic. We can get into this too a little later. 188 byte packet size and grouping with like 7 to 1 ratio of packets. VoIP people hit this. Users when they're doing their magic with voice over IP. And what they're doing is aggregating to a single UDP packet at that ratio of 7 to 1. Now, things get a little trickier when you're pushing under 1,500 byte packets. Some workloads will, with, say, that audio, be a whole lot of little packets and not be what we're discussing. I will leave that to the experts, but we are not living in the 90s. Let's not configure our networks like the 90s are here. So, a little further down the stack is the VPN encapsulation and MTU rules. Those still crop up, but that's not saying just jump into jumbo frames. And one quick thing about a big old MTU is that each device might redefine jumbo very differently. Related in that networking is now the fact that SMB and NFS have some notion of multipath. And there are very different use cases of hitting a NAS with a user or an application or wholesale data center to data center replication. Very different use cases, very different requirements. A lot of LAN for one, a lot of WAN for the other. And naturally people think let's aggregate all the things with LACP and other link aggregations, or wow, there's now a Latvian made 100 gig switch, 16 port for $2,000. I hope that can solve some problems for you. And true eyes on the prize, what is that formula we should always use to match your network packet size to your ZFS record size on disk? Garrett, it sounds like networking brought you here. What are the challenges you are trying to face on mic number 4?
Well, thankfully, mostly none of these. But certainly some of the things from the previous slide, is we have users with the one before. We have users with let's say a wide variety of access networks, anywhere from 200 gig down to 1 gig. And, because our users are university researchers and they're cheap, generally the newer stuff tends to be faster, but that doesn't necessarily mean that they will invest in the network infrastructure that their newer stuff is connected to, and so they blame me because their storage is slow rather than because you're still on a 1 gig switch and you're sharing it with 30 other nodes. So that is certainly like the biggest issue that we have. But we've also noticed that, even when the network itself is pretty unconstrained, it's pretty rare for our users' actual loads to be anywhere near the network capacity. Unless it truly is a 1 gig access network, in which case, yeah, they can just totally saturate that easily. But for most of what, and again, this is kind of like our users are mostly machine learning / computer vision people, at least. Well, those are the ones who actually have the petabytes of storage. Like everyone else is kind of in the noise compared to them. And one of the things that we've been trying very, very hard is to get them to understand that round trips cost. And so much of what they do is opening 100 million files one at a time with like a 15 directory long path name. And do you know how many round trips that takes in NFS? And, and again, they think, oh, the storage is bad, but no, the storage is actually, it's not even noticing what it is that you're doing. The storage is perfectly happy, but the network is eating all of your load times because you are trying to read 100 million tiny little files in a way that can't be cached and in a way that basically maximizes the number of useless round trips. I have tried, for example, to get people to do things like, hey, instead of turning this, MPEG-4 file into 100 million individual frames, why don't you just create an index so you can seek in the MP4 file and read the frame out as you need it? Because, if you're holding the file open, seeks are free. But unfortunately, as I mentioned before, there is no API for grad students. And basically, grad students will do whatever the cheapest, simplest, easiest to find on Stack Overflow thing is that gets them towards the next paper and eventually towards finishing their thesis. And mostly the faculty that they work for don't want to pay them to re-engineer their ML pipelines. They want to pay them to discover new stuff. And that makes it very difficult unless we have some new faculty for whom that's actually a little bit of an easier message because they've come from other institutions where they were already forced by lack of resources to do some of this work. But mostly because we can't control what the users do, the users tend to do the obvious, easy, but most pessimal thing possible, which of course they don't notice as a problem because if they test it out on their laptop or whatever, it's fine. There are no round trip delays on their laptop, at least not that they can measure. But it gets pretty bad for NFS.
I will reinforce that with a quick motto of the center, which is, we've always done it that way.
Yeah, an interesting one that we came across was a customer that was making a backup product that did disk imaging, basically, but over NFS. So on ZFS, they would have a raw disk image of the whole hard drive from before, and then they had like a Windows block layer driver that would figure out which blocks had changed, but effectively, they'd be doing a DD of the hard drive from this machine and writing it over top of the existing file over NFS, and using ZFS's NopWrite feature which notices, hey, the checksum of the block I'm about to write matches what's already on disk. I don't have to do anything. And so they were just overwriting the whole file with a newer image of the hard drive, and they would only have to write out the bits that actually changed. So most of the benefit without, it's going to use up the network needlessly, but the disk storage space, you get the advantage of almost of dedupe, but without the overheads of dedupe. The problem was the NFS client was sending 64K chunks because that's the default size in NFS. But their ZFS was configured for 128K record size because that's the default there. So that meant they would, overwrite 64 of the 128K of the first record. So ZFS would have to read the whole 128K off disk, do the memory copies to combine that into a new 128K block, calculate the checksum, realize it's the same as what's on disk, and throw it away. Of course, they had, because their workload is linear, they're like, well, the ARC isn't going to help us because we're not going to keep every disk image in cache. So we set primary cache equals metadata, so no caching of the file. So now when they write the second 64K of this multi-gigabyte or multi-terabyte image, they have to read that 128K they just read a minute ago again off disk, do the mem copy to do the second half of that record, calculate the checksum, find out nothing's changed, and then not write to disk. So now they're sending 128K over the network, reading 256K off the disk, and then doing nothing. And repeat for most of the disk image and only writing out a couple of blocks. The ARC's going to make sure that, or the way ZFS transaction groups work out, we're only going to write the 128K once. We're not going to double all the writes because it notices that we just overwrote the block 2 different times in memory. But it was, a lot slower than it needed to be just because the NFS record size and the ZFS record size weren't aligned. And when we, made them rewrite all those images with a new ZFS data set, and suddenly everything was many, many times faster, they were like, you mean that one setting was all of our slowness?
Did you reduce the data set to 64?
Yeah, so we changed the data set record size to 64K because it turns out they couldn't control the NFS on all the various clients they had. Right? If it was just Linux workstations that they controlled, they could have forced NFS to use 128K and been happy.
And it will do it, okay.
But all the different clients were running different things, and there was no way they could try to get all their users to actually configure their NFS properly. And so they had to try to fix it in ZFS by just using a smaller record size.
So I have another issue, which gets closer to the actual ZFS stuff. So we basically always turn compression on because that's kind of what you want most of the time. There's a bunch of optimizations you don't get. Like I think the not write one is one of them.
So not write by default is not enabled if your checksum isn't stronger than Fletcher.
And one of the things that happens when you have compression turned on is that writes into a nearly full data set get extremely slow.
That's not compression's fault. That's the quota system and the amplification thing.
Okay.
There's some improvements in newer ZFS for that we wrote.
Okay, well that would be good to see.
Yeah.
So this interacts badly with the way the FreeBSD NFS server works. The FreeBSD NFS server, when it starts up, will look at the sysctl for what is the biggest possible TCP buffer I can have. And it will just force all the socket buffers to be that big. Now, as I mentioned before, we have some users on 200 gig and some users on 1 gig. This is a problem if you're all going to have the same size socket buffer. And it's a particular problem if sometimes writes get really, really slow, because that means that you have some users who can basically exhaust all of memory on your server without not even intentionally, and crash it just by writing into a nearly full file system. And of course, they don't pay any attention to stuff like, is this file system full? Is this file system close to being full? They just, they wrote their batch job 5 years ago. They're now about ready to publish their thesis. They need to run these results. And they just start it, and then they go off and have a life. And the job keeps on running. And eventually the server crashes, and I get paged. And I think, between that and sort of the somewhat, because that also causes the noisy neighbor problem, which is one of the reasons why I now have approximately 20 servers and not like the 5 or 8 that I really would prefer, is because the users don't want to be in a situation where someone in some other group could use up all the capacity of the server and then they can't get their papers submitted in time. Because, especially, again, as I say, most of our big users are machine learning, computer vision. There are 4 big conferences in that field. All of them are submitting to those conferences. They all have the same deadlines, and they all need to get their work done simultaneously,
Interesting.
which is why they all have their own servers now.
Yeah, one best practice for that case for sure is creating a data set with a reservation to save that last terabyte of space for me, and to make sure that the users can't actually fill the pool all the way. And then obviously data set quotas and so on to try to keep people in check.
We've never had an issue with the pool getting full. We don't let the pools get full.
Right.
We have the issue when the data set gets close to quota.
Right. Yes. In the quota, part of the problem there is ZFS. When you have data that's in flight that we haven't written to disk yet, ZFS assumes it might need the worst possible case, which is 12x that amount of space to write it out. Because you might have a RAID Z3 with copies equals 3 and all the other possible things that could happen where that would take a lot more space. And so when the amount of data you're about to write times 12, it reaches the limit of how much space you have left, ZFS stops and says, we have to flush this out, actually write it to disk, and see if we have any more space so that we never accept a write for where we wouldn't have room to actually write it out.
And that's why all the writes get serialized and performance goes to pot.
It causes the noisy neighbor problem, whereas because you're doing a pool-wide transaction group flush, you're now one data set being near the quota is affecting other people who aren't anywhere near their quota. And it can really damage stuff. And so with our changes, we have I think it's a setting where they can go like 3% over the quota with the inflation in order to try to smooth that out and not have it just murder performance for the whole pool just because one person is near their quota and is trying to write. But we had to do a different version of that patch for zvols because zvol has a fixed size. You're never actually going to be able to go over the quota. You're always just going to be overwriting existing data, but it still applied the same effect. And so your zvol could get hit with this performance and drag down the whole pool for no reason.
Thankfully, I haven't had to deal with zvols in a very long time. So
that for your students, right? Is throwing more networking gear the solution to solve the 200 gig versus 1 gig problem? Is that the only solution? Because
Repeat the question when you.
Yeah, so your guest's question was, is throwing more network gear at it and actually just not having a mix of 1 gig and 200 gig a solution to that?
to some extent it is. That is, what we've been trying to do, but that means, getting faculty to spend money on something other than GPUs, which is not always easy. I think some people recognize that it's necessary, and others, it's like, why am I paying for this? Isn't that your job? Or something like that. Because 1 gig historically for the past 20 years, 1 gig is what we've been providing them. Mm-hmm. One of the issues, though, is that a lot of times they want to be able to do the same compute in the data center as they do on their workstations in their offices or labs. And I'm not putting 200 gig in every office.
No.
So, you know,
One of the things we've done in that scenario is actually have a tax that applies to networking gear. That if you're buying X amount of storage, we take 8% of that budget and put it toward networking. And it's isolated out, and that's part of the whole cycle of tricking it to, hey, we just got upgraded, so everything works better.
it would be great if we could do that. We already have a lab tax, and you know that's what pays my salary. But you know, again,
You need a bigger salary too, so
well,
we can
yeah.
increase that tax, right?
But and one of the things that's sort of a administrative/organizational concern for us in a university environment is that when people are sort of looking at their budgets for grants, if one institution is charging 75% overhead and we're over here charging 85% overhead, then that's going to necessarily reflect badly on our researchers when they are applying for grants. And that also means that ultimately if the grant amount is fixed, that that's money they can't spend supporting their students if they're giving it to us. And when they buy hardware, when they buy capital equipment of any kind, which is these days it's over $5,000 is where we've set the threshold, they don't pay tax on that. That is exempt from institute and lab overhead. And so they have like a really strong incentive to make sure that whatever they buy is over $5,000. Because it's literally, if they buy $4,000, it costs them $8,000. If they buy $5,000, it costs them $5,000.
Jeez. Alan, could you educate us, please, on when the checksum algorithms matter? I've heard it mentioned with the NOPRIGHT a second ago, and I recall ZFS diff behaving differently depending on the algorithm, giving you more or fine-grained information or something. Does
I don't
that
think
ring a bell?
ZFS diff has any difference, but yeah, so the NOPRIGHT, where if the incoming write has the same checksum as what's on disk, you just throw away the incoming data. Requires SHA-256 or better because it assumes the chance of a collision on Fletcher 4 is too high.
Interesting.
I don't know if anyone's ever proved it to see maybe it's, overly cautious, but yeah. And the interesting thing is with most CPUs now having support for offloading SHA-256 or 512, you probably can get away with using one of the more expensive checksums without it actually being that much more expensive.
Somebody requested just yesterday or 2 days ago on OpenZFS issue to enable NOPRIGHT for the weaker algorithms with verify optional.
Yeah, a verify option.
Yeah, but that actually made me quick look on a verify code, and I found it pretty much synchronous. Which wonder, did you hit it on your tests, or like how it performed in that context?
For dedupe verify, you mean? Or?
No, for NOPRIGHT, you said.
For the NOPRIGHT, we were using SHA-256 with no verify.
So it was reading just to fill the blocks, but not to...
Yeah.
So honestly, I don't think I have set up a single system in at least 5 years that used any of the weak checksums. Because why bother? I have lots of CPU.
It's never the bottleneck.
Yeah.
Right.
Are all of our Z pools still being created by default with Fletcher?
Fletcher 4 is the default, yes.
It is the default. So that, in other words, hardly anybody's using the no write feature.
Yeah, nobody's else. Yeah, most people don't have NOPRIGHT because of that. It was interesting for a while. It made more sense that if we would set a default, we would go to SHA-512 because it's got about 50% more throughput on 64-bit when you're just doing it on the CPU. But now that CPUs have special instructions for it, the SHA-256 might actually be faster. And it does seem almost like, checksum equals auto, and it picks which one of the strong checksums is the fastest on your CPU would almost make sense there.
Do we have offload supported on all platforms?
I don't think it's supported on all platforms. I think we have offload for Intel and AMD.
No, I mean
and,
for FreeBSD Linux. Or I don't remember when it appeared.
Yeah, I don't know. I got it hooked up on FreeBSD on the ARM V8 version of it, but I don't know the status of all of it on every platform. And it seems like we should get that ironed out.
Do we have x86 SHA-256 offload?
I think so.
Has anyone done science on that? Like in 2024, with your average CPU on your average new server.
Well, what's your average
where
CPU
you at?
in 2024?
It does vary.
My older
but the
Intels
feature
don't
flags-
have either. But
Correct, but
an AMD of the same kind of vintage probably does.
and these are data set properties, not pool level, such that you could
Yes.
say, hey, my checksum algorithm for this, this, and this is this.
And you can change it on the fly. It just only applies to
Indeed.
blocks written after you change it.
Who needs a hackathon project? Just some
So-
simple tests. Just where are
so-
we at?
So if I can ask a related question, so what checksum is used to protect the pool data structures that aren't specifically in data sets?
Metadata, perhaps?
I don't know. I think it's Fletcher for most metadata, probably.
Yeah,
Or does it inherit from the data set still? And the pool uses the root one? Well, one of the biggest mistakes we made in ZFS was allowing the root data set and the pool to be conflated.
Yes.
But yeah, the root of the pool shouldn't have been a usable data set. That was very much a mistake. There's a special really weak checksum for the label, but I think beyond that, everything it uses the one from at least the root of the data set or that data set. But that's a good question. Even if you set SHA-256 as some of the MOS blocks, are those actually written with that checksum, or do they just use the default checksum of Fletcher 4 no matter what?
I remember Fletcher is hard-coded at some places, but I don't remember where this for all metadata.
Yeah.
So definitely, they have different settings for compression. Metadata always compressed,
Yeah.
even if you set disabled.
Yeah, like I think we even removed the ability there used to be a tunable to not compress metadata.
Really?
Never said.
But that got removed a long time ago. And we were wondering about that again recently when we had some metadata corruption. It's like, at least if it wasn't compressed, we could read some of it. But anyway, that's a good question. I don't know the answer off the top of my head.
We have a YouTube question that's completely off topic. So, would it be possible to implement a feature that lists all holds in snapshots by volume? For example, ZFS holds as a command and hold name and volume, if that makes sense.
I think
How
at
do you
one
list
point
holds
on
currently?
FreeBSD, I added like holds -r that could recursively look through a data set for any holds. Are they looking for all holds with a specific name or all holds on a specific snapshot?
All holds in snapshots by volume. Is there wording?
Yeah, so probably.
Okay.
And I implemented a version of that at some point on FreeBSD. I don't think that survived the transition to 2.0, but I had always meant to go back and do it differently anyway. The way I wanted to do it was to be able to do that holds, but also to specify a range of snapshot names using the snap spec to find all holds in a certain range recursively across many data sets. The confusing part from that YouTube question is the word volume, since there's no such thing in ZFS, and what that means to people is different all the time, and it always confuses me. I doubt it means a zvol, and I'm guessing they mean the whole pool, but it could mean many different things.
Now only by snapshot.
Right. I think for one specific snapshot, that's what I did implement at some point. So holds -R and then a data set at a snapshot, and it would let you see all the holds on that snapshot, even if it was recursive across child data sets.
And just adding on that, why have we been, so if you look on the community, like, to get snapshot sizes, the actual size of a snapshot, it's always a pain, right? So you have to do -N, -B to do like a recursive to get the actual snapshot size, but -O space does not give you the right size. So why have we not given like just a simple command? Okay, give me a list of space that space that is occupied by snapshots. So using this.
Yeah, so Yoges's question is, when you do ZFS list on snapshots, the used column will show how much data is unique to that snapshot, which is effectively how much space you would get back by deleting that snapshot. However, if there are blocks that are shared by 2 or more snapshots, that size doesn't show up on either snapshot. So if you have, your 2 oldest snapshots and each one says you'll save a gigabyte by freeing it, by deleting it. But if you delete, and if you try to delete one or the other, that's how much data you get back. But if you delete both, you might actually free 8 gigabytes because there's blocks that are shared between the 2. And in ZFS list, there's no way to, like ZFS can't figure out who to blame for that data because the answer is multiple people. And so it just doesn't show it at all. And the size you get is how much you would get if you delete that one. But to figure out how much you would get by deleting a range of snapshots, the only way to do it is run the ZFS destroy with verbose and no-op, and then it will do the math and tell you. But it's should there be a better way to just figure out how much space you would get by deleting that range? But the problem is, how do you specify that range? Or maybe there's a way you could tell from per snapshot, but it would have to be what other snapshots are you willing to delete? There's not a good way to do it, and that's why it doesn't exist, but it is very confusing to the user.
It seems like at least there could be a property that shows the size of shared blocks included in this snapshot.
Maybe. Yeah.
Shared with every snapshot.
Yeah.
But you have to go through every snapshot that exists to maintain that as it changes. That's when you do the non-destructive operation, you get the real number.
So by default, the columns you get are used for how much you'll get back by freeing that one, and then refer, which is the total live amount of data in the snapshot. And then there's a hidden property called written that tells you how much has changed since that snapshot. But that's not the answer either. So maybe another hidden one like written, but I don't know the mechanics of it.
The reason I brought this up was this seems to be a very common problem.
Yes.
Everybody faces that.
Very
And,
confused.
we don't have a solution for all these years. So that's maybe a useful thing to add.
Is there anyone here not familiar with the written property? God's own property? Alan, can you describe a few more aspects of written, because
I don't
It's-
remember the mechanics off the top of my head, but it's a way to tell how much of the data in this snapshot has been replaced since it was made or something. It's useful to know, but it isn't related to how much space you'll get back for deleting it.
correct, but it's very useful to know.
Yeah, if you looked at my bash history on any one of my servers, there's always ZFS list -O name used written refer, because that's basically the thing that I need to look at, managing to try to figure out what the hell these users did that they've run out of space that I can delete.
I had customers coming back to me saying, hey, this I have like 10 terabytes of used space, use the snapshots, and I'm gonna tell them, okay, if I delete those snapshots, why am I getting more space from you? That's the same question you answered, right?
Yeah.
It's stored more.
To the holds thing, That's actually fairly simple to script away. I know I've done it before. I don't know if I actually wrote it down anywhere, but I'll figure it out again and post it after the end of the conference, though, on one of the things.
Yeah, but I think the advantage to building in is that you're making fewer round trips to the kernel and can make it a lot faster to get that list.
Absolutely.
Yeah,
Yes.
I had something of I may have missed a chunk of it, but if you were trying to figure out, going back to the example, if you've got two data sets, they're both sharing some amount of information, or some amount of data, and you don't know, where this phantom data, whether it's going to be 8 gigs or a terabyte or what have you. Why wouldn't, as a quick and dirty way of figuring out, cloning them out and then deleting those two? Would that,
So for clarity, these are not two different data sets. They're a series of snapshots of one data set.
oh, okay,
And so,
I see.
So if you wrote some data, took a snapshot, write more data, take a snapshot, write more data, take a snapshot. Anything you deleted before the third snapshot is now in both the first and second snapshot.
Okay, that makes more sense.
If
Yeah.
deleting any one of those snapshots will only delete the files that got deleted during that snapshot, but deleting both will now cover anything that was deleted after both of them. And so there's this kind of third amount of space that suddenly comes back, but only if you delete both. If you delete either one of those two snapshots, you'll get back only what it says you will. And then the other confusing thing, to Yogesh's point, is when you delete like the middle one, the size of space you'll get back for the other ones will adjust, because now that data is only referred to by one. And so deleting this snapshot made the one above it suddenly report that it's bigger now, because that data will suddenly actually be freed when you delete it.
Cool.
And so, yeah.
Terrifying, but cool.
And just doing the ZFS destroy no-op is definitely a lot faster than cloning it and making a bunch of changes.
I know we kind of got into data sets and the topic kind of started with LAN and networking, but so I'm kind of going to throw it back that direction. As we know, when you're dealing with the storage arena, which is kind of my area, I spend most of my career disproving that it's the storage. And that's just, everybody knows. When you say it's a network problem, what do they say? No, it's not the network. You know what I mean? And then you spend hours and days trying to prove, yes, MTU set wrong. Maybe they didn't flush the router cache. Maybe they had the wrong route. You end up having to prove it. So long story short, coming back to ZFS, it seems to me that there's kind of this ongoing battle and discussion of whether we should just use iSCSI or whether we should use the way that ZFS presents NFS. It seems the latter is another layer of abstraction, which is going to be slower in my opinion. But I'm just curious, going to throw it out to the council as far as a discussion point, people's experiences, specifically to kind of make it a little more focused, is, in the virtualization world. Everybody's using VMs or containers or something nowadays. So in one of those environments, now you've got the beavers versus ducks situation of, are we going to use iSCSI or are we going to use NFS? So from my perspective on the storage side, when the system receives it, the file system is just going to do what it's going to do. ZFS is going to do what it's going to do. So I can't really think of any specific network criteria other than just try to, based on your environment. But that's why I'm wondering, is there something maybe in your experience or other people's experience in the virtualization world where maybe there's something that in the NFS area that's better than iSCSI? That's what I'm asking.
So, I can say specifically, my users want files, not blocks. For the backing store for our OpenStack cloud, which is a different part of my group that thankfully I do not have to touch, that is all actually Ceph, because OpenStack really wants blocks and not files. And we actually, before we deployed that, we had some Dell weird ass iSCSI storage platform. And, basically every time there was a little blip on the network, that basically destroyed everything that was using it. Because certainly, at least in 2014, Linux iSCSI initiator just absolutely sucked, and particularly sucked when it came to dealing with network issues and other kinds of intermittent things. And so, that experience led us to something that was not iSCSI because we cared more about reliability. We're a very small team. We have basically 5 people supporting 1,200 people. And that really meant that we needed something that was more reliable. And we didn't have the budget or the ability to go out and spend $1 million on a EMC or Isilon or whatever. So that was the solution that the virtualization guys came up with. And my users, again, they're machine learning people. They just want 100 million files that are all accessible to all of their compute nodes, and that they can write to, or a place that they can store checkpoints to, and then load on another compute node later without having to spend an hour before every job of synchronizing things around, which is what most people in big HPC environments do. Is their pre-job environment is move all of the data to the compute node, and then their post-job job is move all of the results from the compute node back to someplace that I can get to it. And our users would basically, they would hang me if I made them do that, which is why we do NFS for them. I wish we could do something more secure, because right now we have a number of users who they don't have regulated data, but they have regulated adjacent data. And for them, we basically tell them right now, okay, you have to go and buy your own storage server and buy your own network, and we'll build a private network for you that you can put this data on. But most of our stuff is on the internet. Literally all of my servers are on the internet. I can get to them from here. We do block NFS at the firewall, but
It sounds like your environment's a little more niche because you're dealing with issues. But I'm sure other folks have, VMware, Proxmox, Hyper-V or something, and I'm wondering if anybody else has any experience in that on the virtualization side, whether or not how they've set it up.
No, I'm not so much an administrator, even so I had some of my own VMs for development and things. Well, I have some small production, but not big. On NFS, I did like to store files as files, even so in case of VMware files only VMDKs. It doesn't store end user files, but it is slightly better than nothing if I need to restore one VMDK from backup or one VM from backup. That's much nicer. On the other side, NFS only, either NFS or SMB, only recently grown copy file range, only recently grown, I think, hole punching that was never supported, which were for iSCSI supported long before. So Xcopy was supported for, 10 years probably. Trim was supported for another 7, 8, 7, 10, I don't remember how, but was supported for a while. For NFS, it was third-party protocol extensions that require some plugins here and there and were ugly. We were trying to do that as plugins for TrueNAS, but that required to be written on Java, installed on VMware side. Third-party protocols working through several different RPCs with NFS. That was not very convenient. Now, definitely with NFS growing to 4 point something, we have server-side copy. I think we have hole punching, should be, I don't remember, but server-side copy definitely do. And with that, maybe air gap will slightly close. Yeah, the one annoyance that NFS always require in implementation of VMware is always require forcing always that for many people create confusion and reduce performance. But to be fair, iSCSI required to be set on a server. sync always, otherwise you wouldn't get reliability. So it's some more like user understanding things, even so they are not so dramatic in practice, not real difference.
Where do you want your control point? Right. That's what it looks at.
Yeah, like I've seen in production every different combination. One of the customers, an engineering firm, uses like each of their ZFS systems is basically one giant ZVol. They export over iSCSI, and VMware formats that as VMFS and puts all the VMDKs in it. And then ZFS means with compression and so on that they end up with more space than if they just use something not other than ZFS. And that works well for them. A different customer runs backups and so on, and so they have NFS and they just put all the VMDKs on it. They don't do as many data sets as I tell them to, but they have at least more than, it's not all just in the root of the pool like some other customers.
Are the VMs live in that pool?
Yes. Yeah, so these are a VM that's live that's just running the Veeam software to receive the backup and write it to that VMDK. And similar. Another customer is trying to have their system orchestrate to have a separate iSCSI volume for each VM, but it means that when they create a new VM, they have to orchestrate creating those zvols on the ZFS machine and exporting them and then connecting the right ones to the right VM. And
Multi-tenancy, that's a good thing.
yes. And in general, like it gives you a lot more control over who's using how much space, and oh, if someone's data is more compressible, then maybe we let them have more space than the person whose isn't, or just being able to use the per dataset stats that ZFS gives you to know which VM is making my storage busy, and maybe using Pavel's rate limiting to keep the noisiest neighbor down to a dull roar, and so on. But yeah, a lot of them, the reason why they go to NFS over iSCSI is the coordination of creating a separate ZVol for each VM is really difficult. Like I think Proxmox has a plugin that tries to work with TrueNAS, but it's a big block of Perl that doesn't really work very well. And short of having something like VMware that can do a VMFS to take one ZVol and chart it up to a bunch of different VMs, NFS seems to be the lower overhead on the orchestration side. Haven't done enough benchmarks to tell you that, iSCSI versus NFS, one of them is a lot faster than the other or anything like that. But like Mav said, especially if your NFS is older and doesn't support, trim and hole punching and so on, then it might be a problem. And of course, with Proxmox, if you're doing hyperconverge where the storage and the computer are on the same node, then it's easy to have a separate ZVol for each VM. But you don't have the ability to migrate the VM to another machine easily.
So in theory, if you're using NFS and you have delegation turned on in v4, then you might actually get some advantages to that versus having a pure block interface, simply because NFS can tell you, hey, okay, you can just cache this and flush whenever, as opposed to the way
Although
typical
iSCSI
block
had
storage.
offloads for things like that to trim and the server-side copy sooner, but now that NFS is caught up, it might have negated most of the advantages of iSCSI.
We have time for one last question from Andrew. who's
Well, not
been
really a
back.
question, but
War story.
not even that.
Not even that.
I ran it on iSCSI, which I ran into kind of the same problems of Linux. iSCSI at the time was not great. And so we moved everything to our ZFS serving out Fiber Channel. And then lately we've been doing NFS. And what we found is if you were treating each one of these virtual disks as not as a block device, not a big deal. If you're treating it where you've got access to the files and handing NFS off that way, then it ends up, at least from what I've seen, to be fairly useful in that your ZFS system now understands all the files. So there's that to consider.
And breaking news, we had a follow-up question from the previous holds question. Alan, I showed you that. Make sense?
Go ahead and read the question.
So why can't one import a checkpoint in read-only mode with another name without exporting the current pool? Oh, a full pool
Yeah,
checkpoint.
so you have a
Okay.
pool imported that you have a checkpoint of from some point in the past, and they want to import the pool at that checkpoint, read only under an alternate name so they can access the old data without having to export the current one. I don't think, any practical reason why you couldn't do that. It's just that ZFS hasn't, the right little bits haven't been wired
Hasn't
up
been wired
to make sure that you don't have the conflict in the name of the pool. Because as Don discovered when we did the, I guess it was for asynchronous teardown of the ARC, when we import a pool in the ARC, the GUID the pool uses is not the GUID of the pool, it's a randomly generated one. And so we wouldn't actually get the conflict if we imported the same pool twice, as long as the one was read-only and an old checkpoint and not. Yeah, as long as it's completely read-only and it's hard read-only, that should be possible. And that's probably tractable enough that someone could do that at the hackathon on Tuesday.